Good afternoon, everybody. Let's see if this is going live first. Okay, I'm alive. Okay, good afternoon, everybody. My name is Greg. I'm from GregsTutoringNYC at gmail.com. I'm a tutor. I mainly tutor elementary school kids, particularly on specialized tests, whether it's the SHSAT or the Hunter test, or the Baccalaureate or the Beacon test, or even just the New York State ELA and the New York State math tests. Normally from grade 3 to 8, and especially on all of the admissions tests. I find it very fun. It's very exciting. There's some changes going on every year with all these tests, whether it's the New York State test or the specialized high school admissions test or whatever. You can get me down and below. Subscribe to me. I'm going to keep building this channel into other aspects. Right now what I'm doing is a little series here. I already did 2 videos about grade 7 and 8, the New York State math test. This is a third one. This one, the other 2 are grade 7. This is going to be about grade 7, and then I'm probably going to flip into 3 of them based on grade 8. The premise being that I often get asked by a lot of people what's the topics on these tests, and particularly with the SHSAT, the New York City Specialized High School Test, but also there's some confusion that kind of happens at the older grades, and depends what's happening. For instance, grade 3 is important because that's normally the first state test that a kid has had. Grade 4 becomes important because it's actually the grade 4 test and not the grade 5 test that's directly related to the child going to middle school. And it should work the same way if you're going into high school. It's really going to be a grade 7 state tests that are involved with going to high school. And there seems to be some political and also technical issues going on with the New York City Specialized High School Test in relationship to the SHSAT. So there might be other changes. So this kind of changes the dynamics of things a bit. Whereas the grade 7 and maybe even the grade 8 state test is going to have more significance. I originally came up with this idea at the end of last year because too many people were asking me what is actually on the grade 8 SHSAT and the grade 9 SHSAT. I know I'm talking about a lot of time frames and a lot of grades here, but and I already started recently getting those same kind of questions again with people because the scores were just released for the SHSAT and the high school offers were made, and people are kind of wondering what really are the topics on the test. So what I'm probably going to do is a series of these. I mentioned there's going to be 3 7th grade, 3 8th grade. I'm probably going to continue it past that. That's why I've labeled this pre-SHSAT, also grade 7 and 8. It's all combo together. Remember that if you're doing the grade 8 test, that you're supposed to have mastered grade 7. Same if you're doing the SHSAT. You have to master these topics. So we're going to go through them and see what's going on with some of these. All right. So I've done enough talking. Again, I'm Greg at GregsTutoringNYC at gmail.com. You can see it below. Please subscribe, and we can get off on a good start. Just one note. Obviously, I'm doing this live. This is not taped. So if I make a mistake, I'm going to try to catch it. I'm not perfect either. And it shows to be demonstrative that test anxiety is real because I'm here real, and if I make a mistake, my only alternative is halfway through this is to delete the whole video. So if I make a mistake, I'll try to correct it. I might put it in the comments. On the same note, I'm going through this at my own pace here, and it's going to take half an hour to an hour to do the 10 or 12 questions or whatever there is here. This one has 10, I think. So if you want, you can pause and start and rewind and replay all these YouTubes. You can go back. Right? What I would suggest is maybe just as we get to a problem, you can halt it, figure it out yourself, and then come back to see what I did. What I also like to do is give alternate ways to get the answer so that just to show this is not one way, because I may explain one way and you're like, what's he talking about? I did it this way, you still got the right answer. So there's lots of ways to get a correct answer here. What I also like about the alternative view is that it gives a way to double check your answer. So if you do it way X and you do it over it in way Y and you get the same number, most likely your answer is correct. Okay, so with that in mind, let's get the ball rolling. So the first thing I have up here right now is the reference table. Let me just wait 1 second. I'm going to log on to my phone. I should have done this a second ago just to make sure that this is streaming. Again, if you guys have any questions, you can put them in the comments. You can also email me. Again, it's GregsTutoringNYC@gmail.com. Let's see here. Where's YouTube on my phone? I love doing this. I love tutoring people. So just give me a, let's see, part 3. Put them in the comments. You can also email me. Okay, I just said that. So we're good and we're live. All right, let's do this, people. Let's do this. Okay, I'm gonna put this over here. Okay, so at the beginning of every state test, there's normally a reference sheet, and it's going to look something like this. Okay, it's going to have unit conversions, and then it's going to have a bunch of formulas. Okay, so make sure when you start a state test or any test that you read all directions, that you go through the first few pages. Don't just start from question number 1. In fact, there's strategies where you shouldn't even be starting from question number 1. In any event, page through every page, look at it, look at the copyright page even. Just make sure you're not missing directions or valid information you can be using later on in the test for some reason. Okay, so let's start out here with question number 1. A company ordered 10 box lunches from a deli at $74.50. Each box lunch costs the same amount. Which equation represents the proportional relationship between y, the total cost of the box lunch, and x, the number of box lunches? Okay, so this is a good word problem, and hopefully I don't goof it up. Certain things leap out at me here. They may or may not leap out at you guys. So what we can have is if y, here, let me try to bring up a note thing. I did the pencil thing yesterday and it was not 100% the best scenario. So we have, let's see, y is the cost of the box lunch, and x is number of lunches, or number of boxes, really, if you want to get into it, because we're calling these box lunches. So it says a company ordered 10 box lunches from the deli for $74.50. So it seems to me that if they ordered 10 of the box lunches, that's x, would equal y, right? The number of box lunches is the price. In this case, the price is $74.50. Okay, that's not what they're asking. So, a company ordered 10 box lunches from a deli for $74.50. Each box lunch costs the same amount. Which equation represents the proportional relationship between y and x, the number of boxes? So they're actually looking for a ratio, y to x, okay, which is the same as y over x. All right, so which one of those can give that to us? So remember, in all cases, we don't have to use all information. That's what I did. My first mistake above was that I tried to use all the numbers they're giving, and that's not what the question's asking. So I backed off of that, and I'm re-going through it. So y represents the total cost, and 7.5, if there's 10 box lunches, means the cost per lunch is $7.45. So if we do this symbolically, just using those two, we have $7.45 times the number of lunches equals the total cost, which is more or less what I was doing above with the actual numbers. They don't want you to be using the 7450 from what I could see here. Right. So it's as simple as that. The total cost of lunches over the number of boxes is the price per lunch, and which represents that proportional relationship. It has to be A because that's the only one that's going to match up with the numbers that we just did over here. Okay. We could rule it in B, C, and D. Don't work. C is saying take the whole cost times the number of boxes equals the total cost. No, that's redundant, so it's not C. Let me see. We have a thing here. We can stamp out C. And D is really close to the same thing, because if we do the cross product here, we see that it's 7.50 times y equals 10x. So if C was no good, D is no good. Okay, and this has 7.45 times y equals 10x. But x is the number of box lunches, so this doesn't work either. It also works if you look at the relationship. We have the cost of a box lunch, which is 7.45, is to the number of box lunches is to 10 over y. So that doesn't work either. So we should be getting A here, unless I put my foot in my mouth. Sample number 3. 8, 7, A. Yes, A. Okay. All right. So it kind of meant that the 7450 didn't really come into play, except for computing when we have the relationship here, because that's what it told us. There's a proportional relationship. So that's what I got, the x to the y. And we can see that when we read this here as well. And if we feed it back into feed the answer back into the question, we have 7.45 x equals y. If x is the number of box lunches, in this case using the example they gave us, if it's 10, we get 7450, and we get 7450 equals y, and it says y is the total cost of the box lunches, which turns out to be true. Okay? Okay, 2. All right, here's a nice nasty one. I wish the problem is their notepad here does not have capability to do fractions. However, when you get into some of the show your work answers, it does. I'm not sure if I'm not. What does that do there? No, that only moves it. Okay. All right. So what we have is 3 fractions, and we need to just do the math on them. So we're going to take the numerator by itself. There's a parenthesis around that. It really didn't need to have parentheses around it. This there and there. Those parentheses did not really need to be there because this, when we look at the PEMDAS operations, actually it doesn't follow PEMDAS because the numerator stands alone. And in the event they did parenthesize it, so what we're going to do is make it out of this thing. We're going to do the numerator first. So we have 2/3 minus 5/6. The problem is we just can't do that. We don't get 3/3 and that's 1. Okay, we have to make the denominators the same. So in this case, I think everybody's clear that 2/3 needs to be converted into 6ths. And there's 2 ways to do this. We can either notice that this times 2 is 6, so 2 times 2 is 4. So we get 4 there. Or we can do the cross product, multiply this, which is also called the butterfly technique, and solve it algebraically. Okay, so we just saw the answer was 4. If we solve it algebraically, we get 2 times 6 is 12 equals 3 times x. Divide both sides by 3, and we get 4 equals x. So in either case, we get 4. So now what does that mean? It means the numerator is 4/6. So now what we have is 4/6 divided by 3/4. Okay? So we have a division here. Let's just make this clear what I did here, because this is not the best mechanism. There's a division here. There's a division here. Those are the original fractions. And this division here means this is the numerator. This whole thing is the numerator. And this whole fraction down here is a denominator. Okay? So we need to do that. So what we can do is rewrite it, because we know some techniques to do this. Because basically what we have is, whoops, we have 4/6, and I'm going to put multiple things here because it's the long one, divided by 3/4. So we know that when we have division by a fraction, actually let me do this just to make it clearer. We have 4/6 divided by 3/4. So we know that when we have division by a fraction, what we change that into is multiplication by its reciprocal. So that means 4/6 stays the same. And instead of multiplication, division, we're going to do multiplication by the reciprocal 3/4, which ends up being 4/3. And I made a mistake, which is that I'm using 4/6, and that was just what this mapped into. So we have to do 4/6 minus 5/6. Okay, so this doesn't count. What we're doing, the last bunch of stuff doesn't count because I skipped a whole step. I converted 2/3 to 4/6. And then did 4/6 divided by 3/4, but that's not what the problem says. We're getting 4/6, and we have to minus 5/6, so we get minus 1/6 on the top. Let me go to the bottom of all this, or I could just clear it. So we have minus. Let's see how to do this. Minus 1/6 is the numerator. And 3/4 is the denominator. It's going to work the same way though. Okay, the same thing we've been talking about. So we have minus 1/6 divided by 3/4. Remember this minus sign only applies to the 6th. So technically we could have put parens around here to make sure we're maintaining the integrity of that. Okay? So we get minus 1/6. And again, we flip this over, so it's times its reciprocal. Okay, and again, I have no way to parenthesize that minus sign, so maybe I'll just write it back in there. But the parens I put up just for the previous thing, this is not set up to do that, so we end up getting 4/18. So if we multiply 1 times 4, we get 4. We have to keep that minus sign. So 1 times 4 is 4, or we could do it better this way. This is equal to a minus 1 times 4 is 4, 6 times 3 is 18. And if we simplify that, we get minus 2/9. Okay, let's see, 3 is A. Good, thank God. Okay, I'm getting distracted by these notepads and the arrows and all this other stuff, but that's part of what you have to keep up with the mastery of these things. Surprised I did that because this is actually a simple problem. So it goes to show, be on your toes when you're starting to see numbers that are not kind of making sense. Double check that. Okay, I'm just checking my phone is still producing this. Yes, it is. Okay. All right, so that's question number that. Let me just quickly flip into here and see if this is good too. Yes, it is. Okay. Okay, this deals with probability and statistics again. Which event is most likely to occur? Let me take a sip of this. So we're trying to get the most logical and reasonable and sensible perspective here. In a lot of cases, all the answers to these could be valid. The question is, which is the best valid one? Which is the most likely? Okay, could be they're all likely. And this is often the case where at least one of them is unlikely or totally ridiculous. So let's go through some of these. There's lots of choices being done here. So let's see what's going on. Okay, flipping a fair coin, which means the coin is not weighted. It's 50-50 where you get heads or tails. Which sides labels head and tails, and the coin lands on tail. Is that likely to happen, that the coin lands on tail? Yeah, there's a 50-50 chance. So far, A is the most likely one to happen. B, choose a marble out of a bag with 9 blue marbles and 1 red marble, and the marble being red. Okay, so I'm seeing where they're going here. So the chance of this happening is 50%. It's half. Okay, choose a marble out of a bag with 9 blue marbles and 1 red marble, and the marble being red. The chance of this happening is 1 out of 10, because there's 10 marbles altogether. Sometimes it's just logic stuff. This one's, we have to actually apply math to it. So there's 9 blue marbles, 1 red marble, there's 10 marbles, and what's the probability that you choose a marble, that the marble will be ready to be 1 out of 10? Okay, so what's most likely to occur? A is still, a half is greater than a tenth. Okay, 50% is greater than 10%. Okay, C, rolling a fair number cube. So again, we're talking about a 6-sided thing that's not weighted. So the chance of getting a 1 is the same as getting a 2, 3, 4, 5, or 6, with faces labeled 1 through 6, and the cube landing on a number less than 6. Okay, so the chance of it landing on any number is 1 out of 6. Okay, that's not what it says. On a number less than 6. So therefore, it can be 1, 2, 3, 4, 5. So it seems to me that that's 5, 6. Okay, 5, 6 is greater than a half. It's also greater than a tenth. So far C wins, if I did that right. Let me reread it. Rolling a fair cube number with faces 1 to 6, and the cube landing on a number less than 6. So 1, 2, 3, 4, 5. Yes, okay. Okay, you're spinning the arrow on a spinner. And I don't know why they don't put fair spinners here. with 4 equal sectors labeled 1 to 4, and the arrow landing on a number greater than 1. So that means it could be 2, 3, or 4. So that gives a 3 out of a 4 chance. So that's a 75% chance. Okay, so we want to double check, and I'm gonna have to get rid of this stuff here. So what we're really gonna do is compare 5/6 to 3/4. Okay, let me just double check that we did D right. Yeah, we could do this 2 ways. I'm gonna do it with the cross product first, without using the calculator. So I'm going to compare 5/6, and we're going to test it. That's supposed to be a question mark. Is that equal to 3/4? So when you do the cross product, we're going to multiply this, and then we're going to multiply this. So what we do is 6 times 3 is 18. We're going to put the 18 here. You can either put it above or below, it doesn't matter. And we're putting on this number because this goes up to the top here. So it's saying we're going to make that for this fraction. Okay, and 5 times 4 is 20, applies to this fraction. So that's 20. So now what we're going to do is compare 20 and 18, and 20 wins. So 5/6. So that at the moment indicates it's C. So we're going to double check. We know 3/4 is 0.75. We're just double checking our math. It's alternate ways to do it. That's supposed to be a 7, not that looks like a 3. Okay, so if 5/6 is greater than 0.75, so let's do it. Let's bring up the calculator. And it is. It's 0.883. Okay, so that gives us, what was it, C. All right. These are tricky. Just means going through them. Sometimes you just have to apply logic. This one we actually apply logic and math to it. And each one required a lot of understanding. This, you could argue it's sort of unfair because it's only worth 1 point. There was a lot of work involved with this, so it's one reason to keep your pacing going. Whether you're on the state test, even though it goes all day, you may not want to be there all day. As well, and on the SHSAT especially, that's a 3-hour test, so you want to get through that. Okay, question number 4. Which is the value of the expression below? Okay, so this is another one of these things, so let me try to bring up the notepad and see how far we can get with that, because it's not really fraction friendly in the notepad. So what we have is something within a parenthesis, and then it's being divided by minus 2.5. Okay, so it's clear we have to do the subtraction first. There's 2 ways to do this. One is to do it with the fractions and then do the division. If you notice what I did on the other 2 samplers, is I kind of make a decision whether I want to use fractions or decimals. In this case, the minus 2.5 is already a decimal, and I see that 3/4 can be 0.75, and I see that a half can be 0.5. What I might do is do it 2 ways, just to confirm it. Okay, or I can leave that as an exercise for you guys to do. But basically what I'm saying is it could be 3.5 minus 9.75, and then that whole thing. Divided by minus 2.5. Okay, so let's bring up our calculator. Let me just make sure this is showing on the screen. Not sure it is. No, it's falling off. I played some of the videos back yesterday and some of them are falling off. So let me drag this slightly over. Okay, now it's showing. So now we're going to get 3.5 minus 9.75. And we get minus 6.25. So what we're going to get basically is minus 6.25 divided by minus 2.5. Okay, so what we're going to do is take that answer here and divide it by, I can parenthesize it, or I can use this button under the 3 if you guys can see that, minus 2.5. So we should get a positive answer at the end because we have a minus divided by a minus. And we end up with 2.5. Okay, so that implies the answer is D. Question number 4 is D. Very good. Okay, it's good when things lie, work out. Okay. Okay. I'm gonna venture a shot at this because I don't have the capability, and even the handwriting is screwed up. If we do the 3.5 minus 6 3/4, a technique to do that is to flip it. And instead of doing 3.5 minus 9 3/4, do 9 3/4 minus 3.5, and then negate the answer. Okay, so if we have 9 3/4 minus 3.5. What I'll do is shift this over so it lines up. You can actually see it. Okay, and then we're going to do a subtraction, so we're going to put a tally line under that. Actually, I'm going to make this longer because we have denominators are not the same. So if we come back to here, this is the same as 3. Well, it's not minus 3. It's subtracting 3, and we get how many fourths out of that? We get 2 fourths. So 3.5 is the same as 3 2/4. So what I'm going to actually do is delete that out and replace the half because there's no other way to do it on this, the way this thing is set up. So bear with me 1 second while I do that. So now we have 9 3/4 minus 3.5, okay, which I converted to that. So we're just going to subtract the fractions. Let me bring this up so it works. So 3/4 minus 2/4 is 1/4. And 9 minus 3 is 6. So we end up with 6 1/4, and I said what we're going to do is, if you remember earlier, because we started from over here, let me bring this up, this is 3.5 minus 9 3/4, but we did 9 3/4 minus 3.5. So I said if we did it the backwards way at the end, we have to flip the sign. So that means over here that we have to add the minus sign back in. Okay. And by the way, you can see it's minus 6 1/4, which turns out if we go to the calculator, that was the computation we did before over here. It's minus 6 1/4. So we're still dealing with the same numbers. Okay. And there's a couple steps you can do from this point. You can convert this to the 6 1/4 and then divide by the minus 2.5, and it'll look exactly the same as the calculator is now. Or we can convert to minus 2.5 into a fraction. Oh my God. Okay? So, in other words, minus 6 1/4 is the same as what? We do 4 times 6 and we get 24. So we get 25 minus 2.5 minus 6 1/4 is 6. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 minus 6 1/4 is 24. So we get 25 over 4. And it's a minus. And again, I can't put parens on this properly, so I'm just going to keep going on here. And that whole thing is divided by minus 2.5. So I'm going to put the minus here again. Again, this should be parenthesized. So that's going to be 2.5 is the same as 2.5, which is the same as 5/2. Okay? So what we have is minus 25/4 divided by minus 5/2. That's the same rule we found before. So we have minus this is bad the way this is set up, but okay, minus 25/4. We're going to change, if we had division by a fraction, we multiply by its reciprocal. So times 2/2. Oh, sorry, 2/5. Okay, let's just put a blank line in here. So this is what our problem comes down to. So we can multiply across over. Okay, let me get the pen back here. We can multiply across here and get 50, and over here and get 20. Okay, or we can cancel the 2 and the 4 and the 5 and the 1. That gives me 5/2 if I cancel it out when I get it out. Otherwise, let's go back to just the regular thing. We would get that equal to 50 over 20. Okay, and I don't have a sign anymore because it was minus 25/4 times minus 2/5. A minus times a minus is a positive. 50 over 20 is 5 over 2. And 5 over 2 is 2.5, which is equal to 2.5. And they lived happily ever after. So we get D once again. All right? Okay. That's question number 4. Question number 5. Let's see what's going on here. This looks like an area problem, but let me see. Wallpaper was applied to one rectangular wall of a large room. The dimensions of the wall are shown below. So going horizontally is 42 feet, going vertically is 25.5 feet. What is the total cost of the wallpaper? If the total cost of the wallpaper was $771.12, what is the cost in dollars of the thing in square feet? Okay, so what we need to do is get the area of this. So we're going to multiply this and this. Okay, and then whatever that answer is, we're going to divide that into here. Okay? So that should be easy peasy enough. So let me write that out in the notepad. Wait, let me get rid of this thing because it doesn't let me do both of those at the same time. Let me just make sure this is showing on the screen. Yes, it is. So the area equals length times width, which means we have 42 times 25.5. Okay, and if we bring up the calculator, 42, come on, 42 times 25.5, we get 1071. Square feet. Okay? And we know the price, so what we're going to do is take the price. And let me bring this aside because we want to see the question here. It's not letting me move it. Come on, come on. Okay, there we go. Okay, what is the price cost of the wallpaper per square foot? So this is all the square feet, 1071, and 771 is the price of that. So it's going to be the total minus the price total minus the area total. No, that's not it. It's divided. Which means we're going to have 771.12 divided by the 1071. Okay, if we take that, we're going to get 771.12 771.12 divided by 1071, and we get 72 cents. So that implies the answer is B. This is question number 5. What is this? Sample 3 is B. Okay, good. All right, that's what that means there. We don't need these anymore. Read the question again. Okay, and it seems to fit in there. Okay, question number 6. Okay, if you remember what I was talking about yesterday, I'm going to ignore everything here, and I'm going to ignore everything here. Okay, what I'm going to do is only look at the table first and try to understand it. So let me try to rip that apart. I'm going to look at the title. Hours worked on a landscaping project. I see there's two columns. One is apparently the 3 workers, Edgar, Kelly, and Sean, and the other apparently is the number of hours they worked. What often happens in these problems is they want you to tally up the column. So I'm seeing they're all over 15, so that looks like it's about 50 hours altogether, give or take something. I'm also noticing the fractions. There's a quarter and quarter and a half. I mentioned before about converting things back and forth, maybe into 0.25 and 0.5, but I'm noticing I can actually do the addition because a quarter plus a half is going to give a whole, right? A quarter plus a quarter is a half, and a half plus a half is a whole. So I'm hoping I don't need to do anything else with that. No other fraction thing, no other decimal thing. But we'll have to see what the question is. And I can understand it enough that if maybe they're asking how much Edgar and Kelly's hours are, I just add the 2 of those. There's probably going to be something here about the number of the price they worked at, and something about the number of hours divided into that to get how much each of their distribution of that is. So let's just see how it works out. All right, so I'm going to clear this and go back to get rid of the highlighter and actually start on the words. What I don't like, by the way, is that whenever there's a table, there's often words above and words below. Okay. What happens is if you look at the table first, it's easy to just start looking at the words here. The other issue is you might say, well, your suggestion's no good then. The problem I find is a lot of kids don't read this up anyway. They almost consider it instructions or directions, and a lot of kids don't read instructions or directions, and you need to. Okay? All right? So let's go back to the top. So 3 friends own a landscaping business. So apparently that's Edgar, Kelly, and Sean. Okay. The number of hours each friend spent on the same project is shown on the table below. Okay, so Sean spent the least, Kelly spent the most, Edgar was in the middle. Again, they all did about 15 hours, give or take a few. All right, and we tried to understand that before. So what we're going to do is, in total, they earned $850 for the job. They put 15% of this amount in a joint savings account for future expenses. Then they divided the rest proportionally, based on the number of hours each worked. How much money did Sean receive? Oh, this is a wonderful problem. This is a multi-level thing that we're going to have to just beat to death. All right, so let's try to move this over. It's not letting me move it. So the first, we have a couple computations we have to do. They made $850. So first we have to figure out the 15% thing, and then their pay, their respective payments. Okay, the respective payment means because they did different number of hours, we have to figure that out. So if they're putting 15% away, right, that means their respective payments has to be, this means therefore the respective payments has to be based on 85% of the rest, because 85% plus 15% is 100%. Right? Is everybody following? Just make sure this is going on my phone still. Yes, it is. Okay. 85 plus 10 is 95, plus 5 is 100. So, so we can compute the 15 and subtract it, or just flat out do 850 times 85%, which is that. And that's equal to what? So let's bring up our calculator. Actually, I'm going to just read the question again to make sure I'm actually solving it properly. 3 friends on landscaping business, the hours they submitted below. In total, they did that. They put 15 away. They divided the rest, right? The rest is the 85%, based on the number of hours each worked. Okay, so the rest is going to be whatever this answer is here. So let's bring the calculator up. Where is that guy? So it's going to be 850 times 0.85 is 772. And again, I like to do things double. So 0.85, especially since this is not typing them, 850. We get 72.5. So this is the amount of money they're going to disperse to themselves. The other amount, if we subtract that from 850, that's not what the question is asking here, though. So they put $127.50 in their bank account. That's not what the question is. So we could we could have computed 15% and gotten the $127.50. In fact, let's do that. 850 times 0.15 is 127.50. So we could have taken that and subtracted it from 850. And we still get 722.5 out of it. Okay, so there's a couple ways to do this. I'm trying to show you all the ways. Now what we have to do is figure out how much does each of them get. So what we need to do is figure out the total number of hours they have. So it's going to be 17 and a quarter. And maybe I will just use the 2.5 for convenience of just writing this here. Plus 18 and a quarter plus 14 and a half. So I'm going to run through this in my head. The quarter and a half is 1. I get 30, so I have 31 so far. I'm going to add the 7 to that. I'm going to get 38. I'm going to add the 8 to that, and I'm going to get 46. And I'm going to add the 4 to that, and I'm going to get 50. What I'm going to do is make sure is run it through the calculator, because my old brain ski doesn't work all the time. So I get 17.25 plus 18.25 plus 14.5. And we get 50, and again we can do it backwards. 14.5 plus 18.25 plus 17.25. Again, we get 50. So 50 is all their hours. Okay, so and the question is, how much did Sean receive? Okay, so Sean received 14.5 out of 50. That's his disbursement. He did 14 and a half hours out of 50 hours. So if we pump that through the calculator, 14.5 divided by 50, we get 0.29. So basically it means he got 29% of it. So it's 29% of the 722. And if we pop that in the calculator, times 722.5, we get 209. That 525, and as dollars and cents, because we have to round up, we got 209.53. And hopefully that is one of the answers. Yes, it's A. So if we go to 6, 6 is A, thank God. Okay? All right. question number 7. All right, let's see what we have here. So again, we're gonna proceed through the same thing. We're not gonna read any words yet. We're only gonna look at the figure. So I'm looking at fabric amounts, and we have orange fabric in yards compared to blue fabric in yards. I like to plug in numbers sometimes, so I can see, for instance, that what I often like to do is see where things line up on dots. These connect right there, so I have 0.7 and 0.3. So that seems to me that the relationship is 3/3 or 7/3, depending on how you look at it. Does anything else line up? That doesn't quite match. That one doesn't quite hit. And this one up here doesn't hit, and these two don't either. So this one here is the only one where the X and Y actually connect on a line, and then with a number that we can figure out. There's usually a universal truth here, which is that a lot of these are not drawn to scale, so we often don't know. All right, and things like that. So that's my insight into this. I haven't read the words. I don't know what the question is. So given that, let's now look at the words. Okay, Maya uses blue and orange fabric to make identical wall decorations. The graph below shows the relationship between the amount of blue and orange fabric used. What is the constant or proportionality as shown in the graph? Well, I think I've answered that already, and it's 3/7. So just by interrogating and asking yourself questions about it, you can figure this out. Yes, 7 is C. Okay. So the key was just matching where they intersect on there, where that. In other words, if you follow this line down, it hits it, and if you follow this line down, it hits it. So it hit it at the 0.7, and it hit it at the 0.3. Okay, so that's our relationship of blue to orange. Okay, question number 8. Let's see, what do we have going on here? Okay, there's some nastiness here, so let's see what we can have happening here. Miss Hernandez. So we're going to take this a sentence at a time, and see how far we can get. So Miss Hernandez has $100 to spend on parking and admission to the zoo. So parking and admission. I'm going to put a tilde here because she has $100 allocated. Often in questions like this, you don't know where they're going yet. So they may want to know how much she could spend to go over it, or how much to stay under it, or at least be equal to 100. So the parking plus the admission is going to be somewhere around $100 for now, let's just say. Okay, now they're actually telling us. So parking is $7, and admission ticket is $15.50 per person, including tax. So I don't know if they're going to ask us about tax at some point. Normally when they say it's included, that stays that level. And I'm just doing a quick skim. I don't see anything about percentage rates. So that's kind of a distraction. They didn't need to have said that. Although some kids might get caught up. Are you supposed to pay tax? I don't know how to solve the problem. So they're telling you it includes it. Okay, now they want you to write and solve an equation that can be used to determine the number of people that she can bring to the zoo, including herself. Okay, so there's a couple ways to solve this. One way is brute force, but they want an equation. So what would the equation be? So she's not going to park more than once. So if we go up here to the first line here, where we have parking plus admission, okay, but it's per person. So I wrote A, but it's actually something times A. Okay, and that something is actually what they're looking for, the number of people. So it's going to be parking plus the number of people times the admission fee is going to be actually actually lets me here. So it can be less than or equal to 100. So we know the parking is $7. Okay, We don't know how many people there are, but we know the admission fee is $15.50. Okay, and that's less than or equal to 100. And we actually don't need that star, so we basically get 7 plus 1550n is less than or equal to 100. Okay, and by the way, I'm going to take a little sidebar quickly because it depends on the fonts that are being used. That sometimes you're going to see, in fact, maybe I'll do it here. Yeah. Let me get rid of that. Actually, let me do it in a notepad. Because sometimes kids get bent out of shape, especially when algebra is introduced into your class. So we're going to take a sidebar and then come back to this example. We've almost solved it. So you were taught stuff like 7 times n. That's an asterisk. That's when I shift the 8 key, it shows that. That's what's above the 8. So sometimes you're told this is multiplication. And sometimes there's a little dot you can do, and I can't do it on the screen, so I'm going to put a period for now. 7 times n like that. Okay? And then sometimes you're showing 7 times x, and x is used for multiplication. Alright? And sometimes it's just done like that. Well, this means 7 n's. Because n by itself normally means 1n. There's only 1n. So if I have 1n plus 1n, then I technically would get 2 n's, okay? So that's what's going on there. So there are different ways to write the same things, and sometimes it depends on what font you're having available. If you're using, say, Microsoft Word or something like that, you can do all these alternatives. Even sometimes, even like this one, sometimes there's a special font for multiplication, and it's more of a bold-faced N, okay? So we can even do that maybe here, just to kind of show it to you, something like that, where it's emphasized a little more. And this keyboard is only a divide sign, but it might be the horizontal line with the dot above and below it. So there's different fonts we can use here, and that's what makes it hard. So that's what's going on here. These are all different ways that the fonts show multiplication. So when you see a weird expression that you're not sure, you have to figure it out by context. We have this a lot in the ELA questions. What does this vocabulary mean? Yada, yada, yada. We have to figure sometimes these things out as well here. If you're only doing a text file and you don't have a smart editor, then it might be like I'm doing now. This is a dumb editor. Okay, it's not a smart editor. The one right here, it seems to be a smart editor because it has all these capabilities over here. We can even put the signs, and I'm seeing it, fractions, and absolute value, and sets, and even square root, and even x roots, and yada yada yada. Even there is a drawing thing here. Okay, it's only for that though. Okay, that's kind of silly. I'm gonna discard this. Okay, it should let the drawing in the regular notepad too. Okay, so now we're gonna come back to that just because I was trying to explain what the 15.50 n means. Okay, so now we have an inequality. So let's solve it. So what we have to do is we have a constant on both sides. We're trying to solve for n. So we have to get rid of non-n terms first. So what we're going to do is subtract 7 here. Subtract 7 there. So we get we're going to end up with 15.5n less than or equal to 93. So now, to get n by itself, we have to divide both sides by 15.5. So if we come to our calculator, we get 93 divided by 15.5. And I got 6. So we get n is less than, let me use the thing here again, less than or equal to 6. Turns out, I guess, if I did this right, that they had to come out to an exact number. If the answer was like 5.99 or 6.2, you would have to figure out from there. All right, if it was 6.2, she doesn't have enough money, and if it was 5.99, you can't get a 0.99 of a person, so we'd have to figure it out from that kind of a context. So in this case, it's not less than or equal to, it was actually equal to. So I was assuming the $100 was just a range with the max. In this case, it worked out. So we could have put equal to instead of less than equal to throughout all this. All right. So if I solve this in my head through brute force and came up with 6, and it probably wants me to put my answer here somewhere. Yes, it does. So 6, and if you notice the box at the end over here, that's the units, so 6 people. And again, I made a mistake here because I actually typed 5. I did that on another example here. So it's 6 people. Okay, is there a part 2 to this? No. So this would have been a 2-point question, and that's pretty much straightforward. The key is mapping it into the algebraic expression. Not only the key, but they're asking you to do that. So if you manage to figure out it was 6 without showing the equation, you don't get the points for it. All right? Because it said write and solve an equation. So you have to do both parts, so you won't get the full points for it. Okay? Give me 1 second, because somebody sent me a text in the middle of that. All right, let's go back to this. So let me just make sure this is working. Yes, good. Okay, question number 9. Okay, we got some weird stuff going here with doing something with square feet at the end. So let's see what's happening here. Okay, it looks like we're doing things with circles. Yay, boo. Yay, boo, yay, boo, yay, boo. Everybody, when the ELA hits a poem, everybody goes like, oh, man. And when these kind of problems hit circles, everybody goes, oh, man. But they're really no worse or better than anything else. Okay, so a contractor, we're going to take it a sentence at a time, and within each sentence, a phrase at a time. Let's try to rip it apart and try to make sense of it. A contractor is building the base of a circular fountain. So we have, I guess it's a water fountain. Normally, fountains are round, and the base of this fountain is round too. Okay, on the blueprint, the base of the fountain has a diameter of 18 centimeters. So blueprint is something the contractor uses, just a piece of paper, or it could be on a computer that's smaller in scale normally, and it tells what happens. So it might say an inch is 100 feet or something. So if he measures it on the blueprint, or she measures it on the blueprint, it shows that it's 2 inches, and an inch. There's a legend or a key somewhere explaining what the scale factors are. Then you're going to have something like that. Okay. So it says, on the blueprint, it shows the fountain has a diameter of 18 centimeters. Okay, the blueprint has a scale of 3 centimeters to 4 feet. So it's not only doing a scale, but it's also doing a unit conversion. It's going from 3 to 4, but centimeters to feet as well. Okay, what will be the actual area of the base of the fountain in square feet after it is built? Okay, I hope it's going to be accurate. Round your answer to the nearest tenth of the square foot. Okay, so there's actually quite a bit going on here. Let me just see where we are. So let's start out by figuring out the scale factor thing. So we have the ratio centimeter to feet. Okay, and again, if you were following some of the other videos, it's the same as, I'm going to put therefore, or something like that. Therefore, it's the same as a division, so centimeters to feet division like that. And therefore, if we actually use the real numbers, it's going to be 3 centimeters to 4 feet. Okay? So it says the fountain has a diameter of 18 centimeters. So it seems to me that if we have to get the area of the fountain in square feet, we need to get the diameter also in square feet, because we're going to use our formulas. If you go back to the reference tables, area equals pi r squared and c equals 2 pi r, right? So that's the bug that we want. A equals pi r squared, that's the area of a circle. This one may or may not apply, except there's something you need to know, because d, this is pi d, and this is 2 pi r. So if pi is the same between the two of them, then we see that d is the same as 2r, or r is half of d, or d is twice of r. So there's a couple ways to remember this. One is r is the radius of a circle, and d is double the radius, d diameter. Okay? Or we can just do what I just did with the formula once you see it there. So there's a couple ways to do this and memorize it and yada yada. All right, so let's get out of that. Let's get out of that. So we need to convert this 18 centimeters. So if we have 3 centimeters, is to 4 feet, then 18 centimeters is to how many feet? Okay, again, there's two ways to do this. Let me get my highlighter. One is to notice that this is 6 times more, and the other way is to notice that this would be 6 times more. So the answer would be 24 feet. We can also do the cross product. So 18 times 4. Let me get rid of this. So 3 times x, which is the question mark, equals 4 times 18. And 18 times 4, what you do is to do multiplication by 4, you double it, and then double again. So 18 times 2, you get 36, and 36 times 2 is 72. So 3x equals 72, and we do it on our head. What we can do is also double check it. So we have 18 times 4 equals 72. And what we have now is we're going to get rid of the reference thing. I don't know why that popped up. Divide that by 3, and we get 24. So x is 24, which is what we said before. 6 times 3 was 18, and 6 times 4 is 24. So it turns out that the if we go back to, let me get rid of the calculator. We go to the problem. The diameter is 18 centimeters. Then the diameter equals 24 feet. Okay, and again we're going to use the formula A equals pi. And let me see if I can figure out if this thing has this capability. Yes, it does. There we go. That's going to be r squared. Okay? I wish the notepad had this capability. It's silly they left that out. So if the d is 24, therefore r is equal to 12 feet. So that means if we come down here, we're going to have pi times 12. Let's do this. Can we do that again? Squared. Okay, and that's going to be, I can can we get out of that? Yes. Equals pi times 144. 12 times 12 is 144. I hope everybody knows that. If not, you use your calculator and you double check it. Okay, so this calculator does not have pi. So what we're going to do is throw it in the calculator. And again, this probably won't be the calculator for your test. Actually, let me see. Oh wait, no, it does have pi. Let me see. Let me just pop it in here. Times 144, and we get 452. I was going to demonstrate something to you guys, which I can do the backwards now. So we have 452.3893421. Okay, 5. Let me just do that backwards. So we have 144. Just 12 times 12. That's 24 times. Where'd that go? Got pi. And we get 452.389.421. Okay, now I think I've done all the computations. So what I'm going to do is get rid of the calculator, and I'm going to read through the whole thing again. Just to make sure I've answered the question. Yeah, once an answer in square feet, so that looks like my answer. There's still a part we didn't do yet, but I'm going to get to that in 1 second. Just want to make sure that that number I have is the number I should be having. And then we'll talk about the last point. A contractor is building the base of a circular fountain. Okay, good. On the blueprint, the base of the fountain is 18 centimeters. This blueprint has a scale 3 to 4, so we've scaled up to 24 feet. What is the actual area? So we did 24 times, we did 12 times pi r squared, good, after it's built. Okay, so this here will be square feet. And if you notice, there's one last thing, which they want the answer to the nearest tenth of a square foot. Okay? So this is not to the nearest tenth. So we have 452 dot, so to get the tenth, that's going to round up to 4, if I did that right. Okay? All right, I'm dying first. Let me take a sip of something here. All right, there's a second aspect to this, which is that if we redo the pi r squared thing, equals pi, here, can I copy this? Doesn't let me do a copy? Come on, people. This is bad. Yeah, let me do it like that. Does it letting me do that? Copy. Paste? No, it doesn't. Alright, so what I'm going to do is I'm going to redo this computation right here. The pi times 144. And I'm not going to use pi. So if we have 144 times, instead I'm going to use 3.14. Okay, we get 452.16. Actually, I'm going to write it here. Versus 452.16. Okay, and we're going to double check that. 3.14 times 144. 3.14. 3.14 times 144. Okay, if you notice, this new one, this rounds to 452.2. So now we have two answers, 452.4 and 452.2. What happens is we have to use pi to more digits than 3.14. Otherwise, we're chincing on the actual answer. It wants you to round your answer to the 10th. The last answer to the 10th. Not anything before it. So actually by using 3.14, I rounded pi to the hundredths. If you notice, I can go through some of this. If I have 3.14 1415 times 144. I get closer to it. And if I did 3.14159 times 144, I'm inching towards that the number we got before, which is the 389 thing. But if you notice, the last digit's still screwed up. So when you're rounding something to a tenth, I normally like to go 2 or 3 more points after it. Or in the case of this, if you press pi on here, it doesn't actually show it, but if I hit enter, we get a large number here. We got 3.141592654. Okay, so we can see that it's actually going past that. So be careful here. You're often taught to use 22/7. Do not use 22/7 unless it tells you to. Okay, sometimes they're just trying to make sure that you understand the logic of how a circle is built and how to use it in geometric shapes and yada yada. In this case, that wasn't the point. The point was to actually get the math correct. Okay, so make sure that, and the other thing is not just the 22/7, but you're often told, oh, just use 3.14. If it tells you that, then use it. If it doesn't tell you that, add on more digits. Okay, this is a no-brainer. There's no point losing points. And this was a hard enough problem with a lot of computations. We did a lot of stuff here in the notepad. Okay, and it would be silly because this is a 2-point question. It'd be silly to do 452.2 and only get 1 point for it after doing other work and the knowledge behind it. So don't toss away that one last thing. Okay. So give me 1 second here. I need to check something. Okay, so let me do the next problem, which I think is the last problem on this one. Okay, so we have a nice bunch of whole words here about a word problem. So let's just take it a sentence at a time, and with each sentence we'll take a phrase at a time. Well, that didn't look like to see what the form of the answer is. Okay, it's just a straight dollar amount. So I bet this, so this looks ugly, so there's either a lot of computations or a little computations. Some of this could be misleading, some of it could be appropriate. Okay, I'm just looking at it from it back up, and I'm seeing a lot of numbers, so there's a lot of room for error here. Actually, let me check this. Grade 7, sample 3. This is a 3-point question, so I'm guessing you're going to get a point for the right answers and a point for all the computations or something. So I don't know what the question is yet, so let's just go for this. Again, I'm just looking at this and figuring, oh my God, I'm doing this live. So let's see. The coach for a basketball team wants to buy news for her 12 players. So there's 12 players on a basketball team, and there's a coach. Super Sports is offering a 20% discount on each pair of shoes, which were originally priced $72.50. A 6.5% sales tax will be applied to the discount price. What I like to do, just like the figures, I like to take each sentence one at a time, try to rip it apart, and actually start doing computations. Now, sometimes when you do these computations, it can slow you down, because some of the computations, even with the charts and the tables and the illustrations, they're not going to be what the question are. But sometimes I just do them to try to understand it, and more than likely, I end up guessing right. There's often a residual bunch of computations I do that have nothing to do with it. Those give me the shot that I might make a mistake doing those computations, which is why if you see in a lot of these examples, at the end I like to feed things back into the question and try to rationalize it out. Sometimes when I can, I also like to do estimations to have some idea what my answer is going to be. I don't know if I can do that here because I'm seeing a whole bunch of discounts, sales taxes, prices. I'm already starting reading the second sentence while I'm talking to you guys, and there's a lot of numbers flying around here. All right. So this is one of the questions where I think you really have to read it. It's not even so much it's hard, it's just tedious. So let's see which one it really is as we rip these things apart. So I'm saying there's a coach, and I don't know if the coach is going to end up with shoes. Coach plus 12 players. So that's basically what the first sentence does. Super Sports has 20% discount. Each pair original price was $72.50. These are some of my givens, and 6.5% tax will be applied to the discount price. So at the end, after the discount, because that's how taxes normally work. I guess technically it could be for it. Okay, the same shoes are available at Double Dribblers. The original price is $54.75, and a 9% fee will be applied to the cost of the shoe. So that really means the original price. We can do it therefore. The original price is the $54.74 plus 9%. Okay, because it's no longer. I wrote that wrong. I did that. I don't want to have the wrong numbers. By the way, this is a large group of silly errors that people make, which is that you copy numbers wrong. I just did 54.75 as 54.74. So let me correct those. A 9% processing fee will apply to the cost of shoes plus shipping fee of $5.99 per pair. So that also means, therefore, I'm going to keep with the original price, but the current price, the price is $54.75 plus 9% plus $5.99. Wow. For each pair. What is the difference in the total cost of the 12 pair of shoes between the two stores? Okay, so it seems to me that with Super Sports, I need to get some figure, some value, and multiply that by 12. Because when I get it all, I can do it all. I can do it beforehand and work in the 12. The same for double dribbles. So let me give myself a second and try to figure this out. So there's a couple ways to do this. You go one step at a time. So the original price was $72.50. We're going to apply a 20% discount, so it's 80% of the price. So it's 72.50 times 0.8, and we get $58. Let's move the calculator out of the way. Super Sport is offering a 20% discount on each pair of shoes, which are originally whatever. A 6.5 sales tax is applied to the discounted price. So $58 is the discounted price, and we need to multiply that by 6.5%, which is the same as 0.65. No, it's not. It's 0.065. Okay, 65% is 0.65. Remember, percent means division by 100. So 6.5 divided by 100. And if we look at this is tenths, the 0 is tenths, the 6 is hundredths. So 6/100ths and a half of 1, so 65. Okay, so if we could bring the calculator back up, it should have the current computation. No, it didn't. Let's just throw it through anyway. We're going to do 80. No, we're not. We're going to do 0.8 times 72.5. We got 58, and we're going to multiply that by 0.065, and we get 3.77. Okay, that's the price off. So that's how much is going to be added to it. So if we add 58 back, we're going to get 61.77. So another way to say this is it's going to be the price times the discounted price times the tax. So if we go 72.50 times 0.8 times, and now instead of getting what the subset price was and adding it back, since it's 6.5%, it's on top of the full price. The full price is a whole. A whole is 1 over 1. 100 over 100 is 1 over 1. So 100% is a whole. So if we have 100% plus 6%, we have 106.5%. Okay, or 1.065. Okay, and that should equal the same number. So let's double check that. So we have 72.5 times 0.8 times 1.065, and we get 61.77. Okay, so if I did that right, that's now the price of the sneaker, and there's 12 of them. So we get 741.24. Okay. And we could have enhanced this here and put the 12 here. Around that, got the same kind of thing. Okay, so that was the SS price. So double dippers, where is that? Double dribbers. Let's get the calculator out of here. Can I keep this on the screen at the same time? Or should I bring up the notepad? Let me bring up the notepad, because that might be easier to see the questions on the side. Okay, 54, 74, 75 is the price. A 9% processing fee will be added. So we can do the same thing. We can multiply by 9 to figure out what that is, and then add it back into 54.75. Or we could just say it's 54.75 times 1.09. It's the whole thing plus the fee, okay? Equals something. So let's bring the calculator back up. 54.75 times 1.09. Nope, I did that wrong. 54.75 times 1.09 is that number, and I'm going to do it backwards. 1.09 times 54.75. Nope, did that wrong. 1.09 times. That's why I'm doing this over. It looks obvious, like using the number right there, but I'm making typing errors enough, and I know myself. So we get 59.6775 with the 9% fee added onto it. Did I copy that number right? No, I did not. 59.67775. Let me go to the calculator. So 9% processing fee will be applied to the cost of the shoes, plus a shipping fee of $5.99 for each pair. So we have also 12 times $5.99, or what we could do is just come out to the end of this, because we're not doing it by 12 yet. Add $5.99 to this, and that's equal to, where's our handy dandy calculator? All right, I lost that number. So let's just plug it back in. 54.75 times 1.09 is that bugger, plus 5.99, and it gives us 65.6675. You could argue at some point we should have rounded this off, and we probably should have. So if we had 68, that's going to be 67. Okay? So that's our price per shoe so far with double dribblers. Plus each pair, and I guess it's that times 12. So now we're going to have 65.67 times 12 equals, and we're going to have about $700 again, it looks like. 65.67 times 12. I get 788.04. Okay. Let me just run some of these numbers through to make sure I'm good. 54.75 times 1.09 plus 5.99 times 12. I did something wrong in that other calculation, I think. So now I'm getting a different number. Okay, in any event, now it just says what is the difference. So I'm going to get those numbers. What's the number I should be looking at? So you have 741.24 minus 788. I should have done the other direction, but it's okay. .01, and I end up with $46.77. Okay, and how does it want me to express the answer? Is that the end of this? $46.71 was that? I don't know what was just on the calculator. I believe so. Let me just make sure I wrote the right answer in here. I think it was 46.77. Let's do it one more time. 788. Whoops. 788.01 minus 741.24 equals, let's bring this thing down. Yeah, it's 46.77. Okay. And what I'm going to do is just read everything one last time to make sure I'm even answering the right question. The coach for a basketball team wants to buy 12 new shoes for 12 players. Super Sports is offering 20% discount on each pair of shoes. What's originally that? A sales tax was added applied to the discount price. So we should have done the 72 whatever times times that. Okay, good. That looks okay. The same shoes were here. I want to keep this number here like this because there was a 9% fee and it's times 12 of them. If you were at the real store, it would have all been done together. Okay, so it wouldn't have been rounded up and then added into there. That was the difference between the 7801 and the 7804. I would hope that whoever grades this would allow both answers, because depends how you do it. It doesn't say it was all rung up at once. It just says a 9% fee. So they could have bought one shoe and then bought a second shoe and then bought a second shoe and bought 12 shoes independently. Normally it's done as a bulk purchase. So that's where we are with that. All right, and that's the last question. So let me come back to me. All right, so this is 3 grade 7 samplers. Hopefully it's giving you an idea what's on the test, what's expected from a grade 7 student, what's also expected from a grade 8 student. It's not just grade 7, because grade 8 encompasses all the other years you had before you. So it's not just that, and you can't throw away that other stuff, especially when you get into the SHSAT, or if you want to consider this also, this is prep for Regents as well. So that's another way to look at it. That's not just prep for it's not just pre-SHSAT stuff. It's also pre-Regent stuff. Especially integrated algebra, some of the geometry, and things like that, okay? So what I'm probably going to do the next time, I don't know if it's going to be today still or tomorrow, is start some of the grade 8 samplers and just run through those and just see where we end up here. Theoretically, the grade 8 stuff is going to be harder. I don't know if it's the case. I haven't seen it yet. We'll do it live and figure that out. Yeah. So again, I'm Greg. I'm from GregsTutoringNYC at gmail.com. I do a lot of specialized testing help. And as you can see, it's tedious, it's error-prone, and you need to keep on your toes and be getting up with it. And with that, speaking of toes, here's fingers. Peace out, people.